Hey guys, so let's look at this question. So this is a question whereby they have given you to calculate the lattice energy instead of the enthalpy of formation. So oftenly they give to calculate the enthalpy of formation, which is a straightforward question, right? Now today I want to look at a case whereby instead of telling you to calculate the enthalpy of formation, they have told you to calculate the lattice energy. So the question is saying that using the data provided below, draw the Haber cycle and calculate the lattice energy for potassium chloride. And these are the reactions given. So I won't focus much on drawing because I've already taught about how to draw, especially you all have subscribed to A Plus Academy. The video is there. I've explained. There's a full explanation for this one. I just want to let you know that if you are given to find the lattice energy, you approach the question differently. Okay, yeah, the approach is similar, but there is a part where it becomes different. Okay, and sometimes they might not put lattice energy, they might say bond energy, or they might say, they might tell you maybe to find, okay, let me say any other reaction other than enthalpy or formation. Okay, so this is the other question I'm talking about. This is a very common one whereby they have told you to calculate the enthalpy of formation. This is very common, but if you use the same approach you used to this one, for the other one, like you do everything that's exactly the same, you won't get the correct answer. Here, where they have told you to find the lattice energy, we do it like differently at the end. Oh yeah, initially it's the same, but at the end, if they have not asked you to find the enthalpy of formation, we do it differently. I'm saying these are different questions. In the usually they like bringing these two, especially this one. That's why the majority of the students only know for this one. For the other one, only a few of them know how to go about it. So let's proceed and solve this one. Okay, so we've been given, according to the question, the reactions. So we are going to write when you look at the reactions given, we are going to follow the same procedure whereby for each reaction, I'm going to write the equation. And if you don't understand here, there is a video on A Plus Academy platform where I've taught each reaction, like how to write the equation for each reaction. Okay, so let's proceed. So we are going to start. So the first one is electron affinity, right? And if you remember what I taught, electron affinity is the change of energy that occurs whenever an element receives an electron, right? Now in this case, they have given us the electron affinity for chlorine, so I'm going to say Cl, and it should be gaseous and plus E, meaning that it has gained Cl, and I say -3. I mean the energy is negative 349 kilojoules per mole. And then the second one is, they have given us a reaction which we are saying that the first ionization energy. Ionization energy is the energy required to remove an electron from the element, right? From the gaseous element. In this case, it is potassium that is given. Potassium is given, and when it loses, it becomes positively charged. It still be gaseous, and this is an electron that it has lost. Okay, and then the energy given for this one is 419, right? Kilojoules per mole. So the third one, so the procedure for, I mean, even for lattice energy and any other than the enthalpy of formation, it is still the same. There is just a certain stage where they're going to be different. So the third one is bond energy. Bond energy of Cl2. So this is where like the bond gets broken, Cl2. This is also called dissociation, right? if you watch the video, I've explained this gaseous, and when it dissociates, when the bonds between chlorine and chlorine dissociates, I'll get just two chlorine atoms, right? And the energy given for this one is 239 kilojoules per mole. The fourth one is sublimation energy. Sublimation energy of potassium. Sublimation energy for potassium. Now, sublimation is why you convert like a solid to gas, right? So potassium, this one should be gas. So potassium, which is initially a solid, when we convert it to gas, the energy that is required is 64 kilojoules per mole. Okay, so right here. So you need to take note that, let's go back to the question. So this is the original question. We are focused on this one. Okay. Yeah, so far I've written the first equation up to the fourth one, right? Now, should I also write this other one? Should I also write the other one? Remember, this question is different from the one for calculating the enthalpy. This one, we are calculating the lattice energy. So we do things differently, okay? And make sure that you pay attention. This question that I'm solving, a very few students know how to solve this one. The majority know the other one for enthalpy, not for lattice energy. Yes. So if you know that already, then I think this video is not for you. Like if you know the difference between these two questions, then this video is not for you. Okay, it is for those who don't know, who think these questions, they are like exactly the same, they do the same thing. Oh yeah, initially you do the same thing, but at the end you do different things. Okay, so right now we've written 4 equations, right? Which other equation should we write? So let's go back to the question. So I want you to understand this carefully. So if you've seen, I've written the first 4, right? And this one, we're also going to use it, okay? But what I'm going to write as my 5th equation is not going to be this one. But yes, this one, I'm going to use it for enthalpy formation. And actually, for this question, they have helped us. It is what they have written here. This is the equation for enthalpy formation, right? I'm not going to write it as my 5th one. Yes, I'm going to use it. I'm going to write it for me to use it. But I'm going to write the one for lattice energy as the 5th one. I'm going to tell you the reason why, okay? Yeah, even though lattice energy is what we're looking for, I'm going to write it because we need it somewhere. And it is where we need it. So if you remember, for those who have subscribed, I explained lattice energy, that it is the energy that is required to form a solid ionic compound after reacting the gaseous ions of the compound, of the elements that are in the compound. So meaning that, like in the case where we're talking about potassium chloride, it means that for me to write my equation for lattice energy, I'm going to say, since it's potassium chloride, I think, why should I write it? Potassium chloride looks like this. Potassium, K and Cl, right? So meaning that the reactants there is going to be K plus, which is a gas, plus Cl negative, which is also a gas, to form. So this is where we react the gaseous ions to form an ionic compound. Now the energy that is required is what is called the lattice energy. So this is solid, okay? But for this one, we don't know what the energy is. Okay. Now you might be wondering, but why have I written it anyways when the fifth one is enthalpy of formation? So let me even write the one for enthalpy of formation as well. But I'll write it let me just write it here. Okay, if you want, you can put it as equation 6, but I would rather just like isolate it here. So let me write it. This one, they have helped us for this question, but sometimes they might not help you. So you also need to know how to write the equation for enthalpy of formation. Go and watch the videos. I've explained how to write the equation for all these reactions. Okay, if you've subscribed to A+ Academy platform, I've already recorded for the videos for that. So it is 1 over 2 Cl2, right? And this is solid, this is gas. KCl, this is K. Okay, so now the goal is this. I'm going to I need to see what I should cancel or how I should arrange them so that when I sum them up, they give me this equation. Here's what I'm trying to say. I want, when I sum up these pieces, I end up getting this equation here, which is the enthalpy. Okay. So you're going to see. At first, I'm having K, which is a solid, or potassium. It is here, right? And I'm also having chlorine, Cl2, which is a gas. This is gas. Where is Cl2, which is a gas? It is here. Now, I want, when I sum them up, they give me exactly this equation here. I hope you've understood this concept. You usually use this one when you are dealing with that one for enthalpy, right? Yes, we are also going to use it here, but there's just this little bit of a difference that we're going to have. So, how can I make this one have 1 over 2 as the coefficient? So, I'm going to multiply this whole thing here. I'm multiplying it throughout by 1 over 2. Because if I multiply this times 1 over 2, it's going to have 1 over 2 Cl2, which is what we have here. Okay. And this one is going to be cancelled. I think, let me see if I can write it here. 1 over 2. Yeah. So there's going to be 1 over 2, and this is going to be cancelled out when I multiply 1 over 2 times this one. This 1 over 2, you also multiply it to the energy. Even this one, you're going to multiply it with 1 over 2. So, just that there isn't enough space. So, the new equation is going to look something like this. Let me write it. Let me try to look for some space. It's going to be something like 1 over 2 Cl2. And this one, the 2 is going to go. They're just going to be Cl. And this one, the new energy for this reaction is going to be whatever you're going to get when you say 1 over 2 times 239 kilojoules per mole. Okay, I'm just trying to show like what the new equation is going to be like. This one here. Okay, so this is what we're going to consider. So when we start summing up the energies, I'm going to consider this one, not this one, because I've multiplied by 1 over 2. So when this happens, if you try to observe, let's say we try to sum up these equations. This Cl, this one, is going to be to cancel with this one, right? And this will be cancelled out with this one. This one will cancel out with... Wait, which one have I cancelled out here? This is a gas, yeah, with this one, the new one, okay? The new equation, this one here, it is also a gas. And this will cancel out with this. This one will cancel out with this one. So if you see, the ones that won't be cancelled out are this one, Cl2, with a coefficient of 1 over 2, which is also a gas. This one, potassium, which is a solid, and which one? This one, right? So these are what we are going to get when you sum up, meaning that we are going to get back the equation which they have given us for enthalpy formation. So this, you still need this equation to help you, to help you know like how the energies are now going to be. So at the moment, the energy for this reaction has changed, right? It is going to be this one because we multiplied it 1/2 so that we can get this one. Now we still need to find the lattice energy, but how do we find the lattice energy? So there is this formula that you need to understand. Lattice energy, enthalpy of formation is equal to the sum of all the reactions that are available. Listen, or let me say it is the sum of the reactions, sum of the reaction, the energy of the reactions that are available in the Haber cycle. Yeah, I think that makes more sense. So the enthalpy of formation is equal to the sum of the energies of the reactions that are available in the Haber cycle given. Now, when I say sum of the reactions, what am I trying to say? If we go back to the question, apart from the enthalpy, this one, which other reactions have been mentioned? Let's go back. So, apart from this one, because this one we've already written it, right? We are saying it is equal to the sum of the reactions. We have electron affinity, ionization energy, bond energy, sublimation energy, and lattice energy, right? So I'm going to say, these reactions that I've just pointed at, even though we are looking for lattice energy, since we are trying to come up with a formula, we are going to consider it as part of the reactions that are available. Okay. So, what other reactions are we talking about? Like in this case. So you put the reactions that they have given you in the question. It's not always that they'll give you like all the reactions that are found here. No. Sometimes maybe they might not be sublimation energy. Maybe they might put a different one. So the first one I'm going to say lattice energy plus electron affinity plus lattice energy, electron affinity, ionization energy. This is ionization energy plus electron affinity, ionization energy, electron affinity, ionization energy. Then we will also have bond energy, and sublimation energy. Yeah, I think this is it. Okay, so in short, just put all the reactions that are there apart from the formation, enthalpy of formation, because you've already written it. So now, since we are looking for lattice energy, I'm going to make lattice energy my subject of formula, and then whatever I'll get will be my final answer. Obviously, the difference. If they have, in the question they told you to calculate the enthalpy of formation, you just sum them up directly after doing this, right? Yes. Now we're looking for this one. So instead of having to sum them up, of course, if they gave you to find this, you would have just added the energies of the reactions given. That's what we've been doing all this time. We've been using this formula in case you haven't taken note of it. Okay. Yeah, this is the formula that we've been using. So now, in a case, sometimes they might try to tweak the question. Maybe next time they'll tell you to find electron affinity. Imagine they tell you to calculate the electron affinity. So just do what I've done and make electron affinity the subject of the formula. Maybe they might tell you to find, this is ionization energy. Okay, maybe they might tell you to calculate the ionization energy. So just do what I've done and then make this one the subject of the formula and just start plugging in the energies given, because enthalpy of formation we have been given. Lattice energy has not been given. That's why I'm making it my subject of the formula. These others have been given. Their values have been given. So they can also ask you to find the bond energy. The same way they have phrased the question, they'll just change calculate bond energy. So follow the same procedure, but when you reach A, make bond energy your subject. Same applies, they can ask you to find sublimation energy. So same procedure. I think let me try to, let's go further now. I hope you have understood, but I'll try my all-level best to explain. So it's not always that they'll be asking you lattice energy and enthalpy of formation. Maybe one day they'll bring you these others. Then you'll be like, what is this? So now the goal is to plug in the value. So where it is from enthalpy formation, I'm going to plug in the enthalpy formation that they have given me in the question, which is negative 436.5 is equal to lattice energy. Lattice energy has not been given, so I'll just write lattice energy. I'll make it the subject of the formula. First, let me finish plugging in the values. If you want to use any approach, if you want to start by making this the subject, then plug in the values, then just punch on a calculator. Do whichever way is easy for you. Electron affinity. So, electron affinity that has been given, where is it? It is negative 349, so I write negative 349 electron affinity, then plus ionization energy. Which ionization energy is given? It is 419. And then bond energy. Now, bond energy, if you've seen, it was this one, right? Initially, we had 239. That's in the question. But after multiplying by 1 over 2, it is now 1 over 2, 239. Always remember that this is our new bond energy. Okay. Yeah. So bond energy. Don't write 239 that is in the question. If you write that one, you're going to find that your answer will be wrong because you put the wrong one. The right one is the one that you get after multiplying by 1 over 2. Why did I multiply by 1 over 2? So that I can have this. I hope you're following. So let's go. 1 over 2, 239. Now sublimation energy, it is simply 64, right? Yeah, so what you do, just sum them up. So when I sum them up, I don't know about you. So here first I have 3, which is the enthalpy formation, lattice energy, plus I'm getting 253. .5 lattice energy. Make it the subject. You're going to have lattice energy is equal to, I'll just take this on the other side, right? So I'm going to have 253.5 plus 436. It is 436.5. Okay. So when you sum them up, lattice energy is now going to be let me just try to check. So I have 253. So getting 690. No, actually, here when we took lattice energy here, it was supposed to be negative. Remember? I always remember that. Yeah, so now even this one will be a negative. So now divide through by negative, by negative, by negative. So the final answer for lattice energy is now going to be negative 690. In this case, it is kilojoules per mole. So have you seen the difference? Have you seen the difference? Yeah, so this is how you solve this question. So first step, like just do the same thing that you do. Sum them up. I think I've already explained this part, even the rules. Okay, why I was cancelling out, I've already explained this. Because this video, I'm assuming that you already know how to answer the one for enthalpy, but you don't know how to deal with the one for lattice energy. Or you don't know how to calculate if they give it to find something else other than enthalpy of formation. Maybe let's say they give you this, I've already explained, right? Make it the subject. It's the same way we've made lattice energy the subject. Make it the subject and sum up, just like that. So next time, don't be confused. If they give you the same kind of question, but they just tell you to calculate sublimation energy, calculate the bond energy, calculate ionization energy, calculate what is this? Electron affinity, calculate lattice energy. don't be confused. I just want you to do this. This is what you do, and I hope that you have understood. Yeah, so I think this is the toughest thing they can bring under these kind of questions on Hava cycle. Yeah, this is the toughest one. Trust me, most of you can fail to answer this one. They give you to calculate the bond energy. Then you just see that in enthalpy of formation they have already given you. Lattice energy they have already given you. You might be confused if you don't know what I've just explained right now. So hope that you've understood, and see you in the next lesson. And don't forget to subscribe to the YouTube channel so that I can continue posting some of the helpful videos like this. And feel free to share your views, your opinions in your DMs. If you like this one, like the video, and yeah. And don't forget to subscribe to A Plus Academy platforms tutorials, where I've recorded video lessons for all NS Term 1, Term 2, and Term 3 work in physics, math, chemistry, and biology, where I've simplified and explained all the important things that they bring on the exam and the tests. Yeah, so make sure that you contact me on WhatsApp if you're interested, and see you in the other videos. But don't forget to subscribe to the YouTube channel. Okay guys, so this is our platform where you access our materials. So you access our video lessons. So just click on videos, then depending with the term, if it is term 2, you choose the course. So we have math, all these topics, the videos are here. In chemistry, all this has been taught. So there are full lessons for thermochemistry, all these lessons. And there is even atomic structure, periodicity, chemical bonding, organic chemistry. All the video lessons are here. All these are the video lessons. Even documents. We have solved materials. All the materials are here. Okay. So all you have to do is subscribe, and you access all our materials. Okay. So make sure that you subscribe so that you can access our videos and our documents on our platforms.